Section 4.2 is solving quadratic equations by graphing. A quadratic equation is an equation of the form ax squared plus bx plus c equals 0. The solutions, that is the values of x that make it true, are called the roots of the equation. In order to find the roots, we want to find the zeros of the related function. In other words, what are the x-intercepts of this graph? So let's take a look at how all these different concepts are related to each other. So if we're given the quadratic function f of x equals x squared minus x minus 6, its zeros are negative 2 and 3. If we're given the quadratic equation x squared minus x minus 6 equals 0, its roots are negative 2 and 3. And the x-intercepts of that graph are negative 2 and, I have a mistake there, positive 3. So it's a function if it starts with f of x, and it's actually the function that we graph. It's an equation if it equals 0, and we say that the roots, or the values of x that make it true, are the places where the graph crosses the x-axis when you graph the related function. So we're going to be solving a quadratic equation. It's going to equal 0, and we're going to be solving it by graphing. So we're going to graph the related function. So in other words, this main stuff here is all the same. It's just going to say f of x equals. We're going to graph that, and we're going to find the two places, if there are two places, where it crosses the x-axis. So let's take a look at several examples here. The first one is the quadratic equation x squared plus 6x plus 8 equals 0. So I'm going to graph the related function, which is f of x equals x squared plus 6x plus 8. And in order to graph that, I need to make a table of values, and I need to know what the vertex is. So I'm going to use the little formula that we learned in the last section, x equals negative b over 2a. So that's going to be negative 6 over 2, or the x-coordinate of my vertex is going to be negative 3. So when I go to make my table of values, negative 3 will be my middle value, and I'm going to choose 2 smaller and 2 larger. And why don't we just go ahead and use our calculator to do this for us? So into y equals, I will put x squared plus 6x plus 8. Okay, I can go to my table, and I will enter the values of x that I wanted, so basically negative 5 through negative 1. And I think I'll make the calculator do the work for me here. Okay, and you'll notice, I'll take a look at this larger one on the right here, you'll notice that there is that symmetry in our y values. So let's fill in the table. That's a 3, 0, negative 1, 0, and 3. And let's go ahead and graph those points. So negative 5 and a positive 3, negative 4, 0, negative 3, negative 1, negative 2, 0, and 1, 3. So there's the graph of my quadratic function. And I can see by looking at this that the graph crosses the x-axis right here and right here. So those are the values of x that make this equation true. So that would be negative 4 and negative 2. So those are my two solutions. So when x equals negative 4, my original equation is true. When x equals negative 2, my original equation is true. Now you'll also notice, and this can be very helpful, that those two numbers, those two x values that are my solutions, at those points y is 0, and that's exactly what's supposed to happen, because every point on the x-axis has a y value of 0. Let's take a look at another example here. X squared plus 5 equals negative 8x minus 11. In order to solve this, I need to put it into kind of its standard form, that is, make it equal 0. So I will add 8x to both sides, add 11 to both sides, and I need to graph the related function, which is f of x equals x squared plus 8x plus 16. To do that, I want to find the x of my vertex. So x equals negative b over 2 times a, or the x of my vertex is negative 4. Let's make the table. Negative 4 goes in the middle. 2 x's that are smaller, 2 x's that are larger, and let's use the calculator to do the math for us. So I have x squared plus 8x plus 16. I could actually graph it from here and see what it looks like and see what's going on. That looks interesting. Let's take a look at our table and see what's happening. So the values I wanted were negative 6, negative 5, negative 4, negative 3, and negative 2. And my y values are 4, 1, 0, 1, and 4. Let's go ahead and fill those in. And you should be able to tell right now, just by looking at the table, what the solutions are. What we're looking for is the x value, or values, when y equals 0. And it looks like negative 4 is my only one. So let's take a look at that and see what it looks like when we graph it. 6, 4, negative 6, 4, negative 5, 1, negative 4, 0. And sure enough, this graph touches the x-axis in only one place. Whereas in our previous graph, the parabola crossed the x-axis in 2 places, this one just touches it in one place. So my only solution is x equals negative 4. And that's my one solution. Let's take a look at another example here. So I have negative x squared plus 4x minus 5 equals 0. Let's find the x of the vertex. Negative b over 2a is going to give me negative 4 over negative 2, or the x of my vertex is going to be a positive 2. Let's make our table. Put 2 in the middle. 2x is smaller, 2x is larger, and let's go to the calculator. I'm going to clear that out because now I have a negative x squared plus 4x minus 5. And let's go to our table, and we were putting in 0, 1, 2, 3, and 4. And you'll notice my y values are negative 5, negative 2, negative 1, 2, and negative 2, and negative 5. I don't have a 0 in there. That's curious. Let's see what happens when we graph that. So I have 0, negative 5. Oops, I want pink. 3, 4, 5, 0, negative 5, 1, negative 2, 2, negative 1, and so on. Notice because a is negative in this graph, a is a negative 1, it's going to be going downward like we talked about in the last section. However, this graph is never going to cross the x-axis, never going to touch or cross the x-axis, because its vertex is actually beneath the x-axis, and then it's going downward from there. So in this case, we say that there is no real solution. It's important that you put the real in there, as we'll find out in a few sections. There are imaginary solutions. We'll talk about that later, but for right now, there is no real solution because the graph of this equation does not cross the x-axis. That means that there is no number that you can pick for x, plug it into this equation, that will make it true. Let's take a look at another example here. X squared minus 6x plus 4 equals 0. Let's find the x of our vertex. Negative b over 2a, or 6 over 2, or 3. So let's go ahead and make our table. And let's put 3 in the middle, and then let's pick 2 smaller and 2 larger. And let's plug this into the calculator. So we have x squared minus 6x plus 4. And let's take a look at our table. And I wanted to start with 1, 2, 3, and 4. And that gives me values, oh, and 5. Yeah, I'm going to do 5 also. There we go. So that gives me negative 1, negative 4, negative 5, negative 4, and negative 1. Let's put those in our table. Oops. Negative 1, negative 4, negative 5, negative 4, negative 1. I'm a little concerned because I'm not seeing a 0, nor am I seeing the numbers go from positive to negative. Let's take a look at the graph and see what this looks like when we graph it. So 1, negative 1, 2, negative 4, 3, negative 5, oops, 3, negative 5, and so on. Now when I graph this, you'll notice it's heading towards the x-axis, but it doesn't quite cross the x-axis. So that means that I need to do some more values of x. Let me erase that line, that's not very neat. I need to do some more values of x so it keeps going. So I need to do 0, which is smaller than my smallest x, and I need to do 6, which is bigger than my largest x. And actually, I should get the same thing. So let's do 0 and 6. I should get the same thing for both of them. And notice when I do, I get that y equals 4. And that's going to be a good number because when I go to graph, there's 4, and here's 6 and 4. Now my graph is actually crossing the x-axis, which is what I wanted to do, and continuing up. But notice, it doesn't actually cross at a nice number. It's kind of between two numbers. There are no integral values for x here. There's no integers, no positive or negative whole numbers that represent those x's. So the way we write it is we can say that x is between 0 and 1, because right at this point it's crossing between x equals 0 and x equals 1. The fancy way to write that is like this. X is between 0 and 1. In other words, x is greater than 0, but x is less than 1. And then over here, it crosses between 5 and 6. So x is between 5 and 6. When we write it this way, we always use less than signs because ultimately 5 is less than 6 and 0 is less than 1. So there's no integer that represents the value of x. It's going to be a decimal. It's probably going to be an irrational number, so we're just going to leave it like that for now. So to summarize, a quadratic equation can have 2 real solutions, 1 real solution, or no real solutions. 2 real solutions if it crosses the x-axis in 2 places. Now those could be nice numbers like we had negative 4 and negative 2, or it could be between 2 integers. A quadratic equation can have 1 solution, it just touches the x-axis in 1 point, or the quadratic equation will never cross the x-axis, in which case it has no real solutions.